Now, continuing the previous example, you can see that our decision to write 10 call options at a price of $1.20 and sell them essentially for $1.27 times 100 led me to receive a gain from writing that call option of 1270, but that didn't perfectly cover the loss we had on our long position of 69.60. So we had a net loss, even though we balanced some of that loss by writing a call option. The problem was we didn't write enough call options. Now, if I want to write covered call options, I'm limited by how many shares of stock that I own. Remember, writing a covered call option means you own the shares of stock you're writing the option on. I owned 1,000 shares. Since each call option is for 100 shares of stock, I could only write 10 covered call options. I can, though, write naked call options as well, which means I write call options on stock I don't own. So it's possible for me to write more than 10 call options if I choose to do so. And I think what I'll do here is write number of call options. And I had just written 10. The 1,000 divided by 100. If I had written more than 10, then I would have earned a higher profit. If I write just enough call options and I can get my profit to a positive 69.60, that would perfectly balance the loss that I would have on Netflix, leaving me to a net position of 0, which would be what's called a perfect hedge. I need to figure out how many call options I should write. To calculate that, what I need to do is look at the delta, and that again is how much the call option changes in value for every, or whenever, based depending on how much my underlying stock changes in value. I think my stock is going to drop from, let's say, 76.96 to 70. And what I like to do is see what happens to the value of the call option in that case. So at 76.96, the call was valued at $1.27. I'm just using the worksheet that I used in the first example to calculate deltas. Now, I'm worried the price will drop to 70 over the course of a month, so I need to change this 31 days to just 1 day. If that's the case, there's only 1 day left until expiration. The stock is priced at $70, and this option has an expiration, strike price of $92.50, so there's essentially no likelihood that would be exercised. So the option has a value of 0. So at the current stock price of 70, the option has a value of 0. The change in the stock price would be a drop of $6.96, and the change in the option price would be a drop of $1.27. Taking the change in the call price dividing by the change in the stock price gives me a delta of 0.1825. I'm going to pop that information here. To figure out the number of options that I should have written instead of 10, what I need to do is take 1 and divide it by the delta. So 5.48. And actually, let me restate that. I should write 10 times this value. So I really should write 10 times 5.48. So instead of writing 10 options, I should have written 54.8 options. So what I'm going to do is, instead of having 10 here, I'm going to replace it with this 54.8. So if I had written 54.8 options, I would have received a value of 69,060. That didn't come out right. 6,960 for writing those call options. they essentially would expire worthless and they would never be exercised, so I'd never have to deliver any stock for having written that call option. That would give me a gain on the option of 69.60, which would perfectly balance out my loss on the long position of my stock. So you can see in theory it is possible to perfectly hedge your position, but it's not necessarily that easy. Um, I knew with certainty what my delta would be, but delta is not actually known with absolute certainty.